Swayam Prabha. Digital India. Educated India.
Hi dear friends, welcome to this second lecture of Module 9 on Engineering Geological Investigation for Roads and Highways, Bridges and Building Foundation. In previous discussion, we have discussed about elementary aspects of road or highway, classification of roads, features of roads, pavement and types of pavement. Now in this lectures we will learn about stress distribution in road structure, engineering geological investigation for new road alignment and quality of aggregate with some specific study about the hilly road. In these lectures, we are going to deal with stress distribution and engineering geological facets of new road or highway alignment. Regarding this, we are going to cover about introduction concerned to roadway, highway, new alignment, and then about the engineering geological investigations for road alignment as a new road alignment, and the type and nature of stresses acting on road structure and quality of aggregate along with some hilly road aspects. Friends, as you know, for construction of road, first we have to identify the alignment, safe alignment, comfortable alignment and economical alignment. For this, we are going to make some survey regarding different area or proposed area sanctioned by government authority, and lot of table level preparation and consideration. Then we are going to identify a safe, easy and economical routes and alignment. So the entire alignment which we are going to mark for new road construction, the entire alignment is studied to assess the geotechnical problematic zone present in the way or not, like presence of waterlogged area or swampy area, presence of some peat zone or weak zone, seams and others, presence of some weak rock strata or fissured soil or fissured soils, or presence of some danger zones or presence of some fire zone, etc. This alignment study is devoted to identify the problematic sections and possible treatment of problematic section, the possibility of treatment to rectify the defects or not, then about showing the provision for realignment, etc. For this, first we are going to see about area in general, then step by step we are going to see about different activities regarding the alignment and engineering geological facets of road and highway construction. We are going to see about the assessment of cutting and filling. Friends, as we know that the subgrade is not of defined planar in nature, then as per requirement we are going to see the subgrade. It is made up of soil or it is made up of rock, it is weathered in nature or intact in nature, it is weak in nature or strong in nature. Then as per level of road, suppose the level of road is defined up to this, then we are going to make some provision for cutting this zone to make the level, and other side is depressed in nature, then we are going to fill this material in this zone. Sometimes if this material is not sufficient, then we are going to take some material from other location. The volume of cutting and filling required in different parts of alignment are estimated properly, and the availability of materials such as soil and rocks in the nearby area are determined, and the site for burrow area for soil and rock quarries are to be located properly. If this zone is not sufficient to fulfill the requirement, then we are going to search for rock and for soil in nearby quarry area. Why nearby? To reduce the transportation cost. Transportation cost of material is one of important aspects related to any engineering geological construction or development. Therefore, the assessment of cutting and filling is a very important in construction of road. You can see the cutting and filling either taken by roads, rails and others from other side to the roadside to make this level up to defined and plan design level. Next important to see about the cut slope, to evaluate about the cut slope. Here you can see the cut slope. When we are going to develop this type of road, then we have to see about the slope of this zone. The slope is stable or not stable, what angle we are going to provide to ensure about the safety of slope located sideways of road. As per general convention, if this type of slope, then maximum 30-degree inclination we are going to prefer in safe mode. It means this angle 30 degree is safe for the soily slope. However, in case of rock, it may be extended up to 60 degree or even more, depending on strength, compactability, availability of the interfaces in this condition, nature of joints, etc. Measurement of soil slope and that of rocky sections to ascertain the inclination of the stable cut slopes and measures taken to design for the stable slope. If such slopes are not permittable, then we are going for the treatment, placing some steel nails, rock bolts in case of rocks and others to stabilize slope. We cannot reduce the angle of inclination very low. Low slope automatically stable. But when we are going to put the low slope, it means we are going to encroach more area for road construction. That is not justified socially. Therefore, we try to put maximum angle at which the slope can be stabilized. Nowadays, with some precautions and others, we are even taking angle up to 30 degree because 45 degree is a natural slide angle. So therefore we generally prefer to make the inclination less than 45 degree. So 38-40 degree is sufficient when we are going to install some support system. In case of rocks, we are going to put as high as possible, even more than 60-70 degree. 60 degree is a minimum, 70-80 degree, depending on the nature. If rock mass is weaker in nature, poor in quality, then we cannot give some more inclination, so we are confined to 40 degree, 50 degree, etc. Then important thing is a sampling for the laboratory test. For the sampling, we are going to collect soil samples, particularly in earth road, every 200 to 300 meter intervals to conduct laboratory analysis to know whether the subgrade is able to bear the dead and live load of traffic or not. So in this way, we are going to see about the ultimate bearing strength of soil along with some index engineering properties of soils, to assess about the behavior of subgrade in presence of water in dry season with respect to change in loading condition due to movement of vehicles, etc. Next important aspects which we are going to include in study is assessment of ground condition. This aspect is very important. The whole success of road construction based on ground condition. Therefore, it is very important to evaluate the ground condition of different section, whether this particular ground is suitable to bear the live and dead load of vehicles or not, and able to survive for longer time or not. Durability of road is also important. Therefore, we are more conscious about the ground condition. Then about the demarcation of problematic weak zones with help of aerial photographs. You can see aerial photographs. This aerial photographs are going to show different features. If we are going to decide the road in this way, then we are going to see number of problematic zones, the number of waterlogged area, seams, weak zones, etc. In this way we are going to take precaution. So aerial photographs study is taken up covering the proposed alignment with special emphasis to locate and demarcate the presence of peat or swampy land or weak features or weak zones or fire zones or waterlogged zone, etc. Because these features are going to influence the stability of pavement. Next aspect is the determination of the amount of pitting and trenching and drilling to know about the status of ground. Amount of trenching to see the subsurface status of the subgrade or original ground. It is necessary to determine the amount of pitting, trenching and drilling involved in the investigation to investigate the nature of subsoil condition and the money involved in such type of works. So cost assessment is also important in view of the amount of trenching, amount of pitting, amount of drilling to know the subsurface condition of the subgrade, because the subgrade is the ultimate strata which are going to bear the whole load of traffic along with overlying strata on the subgrade. So subgrade should be strong enough to bear the load of all kinds of traffic and dead load, live load both. Geological investigations and subsurface view, very important to know the presence of rock or soil subsurface to the site. For this we have concept of geological map. Through this geological map we are able to show different lithology, different features and others. Then along alignment we are going to take the vertical section like this to see different features, inclination of beds, presence of soil, presence of weathered zone, presence of weak zones in terms of rock type like shale, like highly jointed rocks, fractured rock, etc. So most important part of investigation to prepare the geological strip map covering the area along the alignment and its neighboring parts by showing rocks, weathered material, soil, etc. to know overall the subsurface condition of the ground where we are going to construct road or highway of different designs. Friends, if we are going to see about the road condition where the vehicles are moving with help of tires, and tire generally in direct contact with the carriageway of the road, going to create lot of wear and tear type of effect. This pavement is able to sustain with wear and tear effect of tires. However, the dead means the weight of the vehicles or traffic at static condition, and life load means the effect or load or stress caused by vehicle's tires during the motion. So base of the tire is in direct contact with this road, and the weight, both dead weight and live weight of traffic is directly coming to, suppose this is the subgrade, this is also some filling. So directly the load or stress is going to hit this subgrade linearly in area equal to the area of tire. In such situation, the whole load is coming in this way. The whole load is directed on this line of subgrade, confined to this limited area AB, which is equal to the width of tire. If the load is acting or concentrated within the limited zone of the subgrade may be unable to bear the dead and live load of tire. Therefore, we have provision of pavement. In pavement, we are going to construct different layers: surface course, base course, sometimes sub-base course in flexible pavement, and then grade. This base course, as you know, made up of some sand along with some angular type of crushed stone. The sub-base is made up of finer materials along with soil to protect, and the upper portion either made up of concrete, either made up of asphalt and concrete mixture in case of the flexible support. First, in rigid supports, here where the slab is made up of concrete, the load is slightly deviates outer side from the contact point. So it distributed for slightly wider area. However, in case of flexible pavement, the different layers, here I try to show different layers present in flexible support, like here surface course made up of concrete consisting of aggregate and asphalt. Then base course made up of angular type of aggregates belonging to crushed stone. Then sometimes if required, then we are going to put one sub-base course made up of some stone aggregate, finer aggregates along with soil and sands, and this is the subgrade, sub-base course, base course and surface course. In these flexible supports, the live and dead load of vehicles coming through the contact between this road and tire is going to diverge downwards, deviate from the original area width of the tire and distributed over large area. Therefore, the impact of such type of stress distribution able to deteriorate very negligible. Therefore, highway and expressway generally be preferred to construct with help of flexible support. However, where the dead load is dominating, like toll plaza and others, where we are going to put concrete load which are able to bear heavy static load, because the heavy static load is mainly directed towards the downward with minimum diversion from the area equal to this width of tire. So in this way you can see this wear surface, base course, sub-base course, subgrade and others going to support the load without any deterioration of road structure. The plain road and hilly road. Hilly road in design wise slightly different than the plain roads, where in plain area we are maximum getting soily slopes and the land almost plain in nature. But in hilly area you can see, this is the view taken from the website for explanation. To cover the height, there is different level of roads connecting each other. You can see this lower level, then upper level, then upper level, then further upper level, and the side of the hilly road is comprised of rock strata as well as some vegetation, some soil cover, some water conduits, water flow routes, etc. One of the important aspects of the hilly road is a slope stability, because such type of roads is made up of rock strata, which are integration of rock mass and rock mass containing discontinuities going to affect the strength of the exposed rock faces along the road cut, and time to time there is instability problem, slight problem, and that slight problem going to create lot of problem concerned to safety and survivability of road. Therefore, in design to fixing the height as well as slope of the strata lying nearby this road or sidewise this road is called as road cut slopes. Road cut slopes are very important to identify first what are the rock type, what are the features present, what is the condition, and about height, gradient, etc. So for hilly road cut, the excavation for road or canal is called as a cut. Without cutting we are unable to construct road because the mountains are on slope. So gradient, height and steepness of the walls, cut walls, are important to study. Alignment of road with respect to the structure, deep and strike of strata, nature of the deep joints, condition of the joint, characteristic of the joints are important. Beside joints, the area should be also observed regarding the presence of fault, folds, orientation of bedding, foliation, lineations, etc. Then about the lithological arrangement with particular reference to the density and cohesion of rock as well as strength of the rock, which are going to influence the slope stability aspect of exposed rocky slope. Flow pattern of the underground water and surface water, nature of vegetal cover and vegetation type, to see about the stability status of cut slope with respect to time in future after construction of road. Because during construction of road, for getting the side plane we are going to involve drilling and blasting for fragmentation of rocks, creating lot of disturbances in strata. So therefore we should be careful about the stability of slope exposed nearby road. Another aspect is a design concern, where we are going to see about stiffness and height of cut walls. Here this height of cut walls, earlier it was mountain, then we are going to cut with help of drilling and blasting and clear a profile. This cut wall height and stiffness ratio is very important, because the stability aspect is depend on the stiffness and the height of this slope wall. Then the presence of joints and others are secondary parameters which are going to further weaken this slope. The height and slope of sloping walls of the cut slope should be kept approximately proportional to the shear strength of rock strata. Not rocks, but rock strata, because the slope is made up of strata. The greater the shear strength, the steeper and longer the slope of the walls, and if less, then it should be lesser. The height should be reduced in nature. If this rock mass is of excellent quality, then we can extend the height at lower inclination so that the minimum area can be involved in construction of road. The same concept we are utilizing in mining also during the design of the benches. We are going to make the bench as maximum possible inclination, so involve minimum lateral area and maximum vertical area to excavate coals and other minerals and others. Same condition we are going to apply here also. We are going to give the maximum, and the height and slope both are function of strength, particularly shear strength of rock mass, because the slope is made up of rock strata. So if the shear strength of rock strata is more, that depends on presence of joint, frequency of joint, separation, spacing, etc., and about the binding capacity of rock and strength of rock. So if strength is more, the height we can make more at a given angle, and the slope angle also we are going to give more. If the rock is weaker, then we are going to give this height is short. If still there is a problem, then we are going to put support system like rock bolts, wire mesh, anchors and others. You can see the number of slope failure along the highway, particularly in Himalayan region. You can see this type of road, hilly road, is slightly different than plain road. Another aspect in hilly road you can see here, this turn in plain area we are putting here slope at the middle to drain out the water, but in hilly regions we are putting this inclination of the road at corners to maintain the turning of the vehicles from balance point of view, otherwise facilitate draining of water near the corner drain constructed nearby the slope walls. Therefore, in hilly region the roads are slightly tilted from outer side to inner side, and sometimes allow the water to flow through road and finally collected in drains. You can see one view of the hilly road. As far as quality of aggregate is concerned, by which we are going to make different layers of pavement, should be here a specific gravity should not be less than 2.6, water absorptions not to exceed 5%, deleterious material like coal, clay, soft shell, mica, opals not exceed to 5% by weight of total aggregate. However, aggregate crushing value not to exceed 30% in fresh sample and 45% in weathered sample. Abrasion value carried out by Los Angeles test not to exceed 10% in 100 revolution and 40% in 500 revolution. Soundness value, that is a chemical test. For sodium sulfate test, for 5 cycles not more than 12%. This specification is as per Bureau of Indian Standard patent number 387 1970 for utilization of aggregate for road construction. Friends, these materials I have collected from different sources, but taking help from the engineering geology book written by Gangopadhyay S, published by Oxford University publication, then partial supports from the engineering geology book written by Bell F.G., then textbook of engineering geology written by Kashabulu N.C., and then some concept related to roads and other from Glossary of Static Term 2007, and some website materials in form of photographs and others. Friends, in this lecture we have elaborated about the engineering geological investigation or facets required are important to identify defective zone, methods of sampling and laboratory method, as well as for assessment of level of treatment, preparation and cost involved in preparation and treatment. The subgrade bears the dead and live load of traffic. Therefore, we are going to make different layers above the subgrade to distribute load for wider area or distribute load in wider area, so the minimum deterioration effect can be experienced by this subgrade. And the selection of subgrade is important for planning and design of the road construction, and the hilly roads need proper design concerned to slope cut both in rocks and soil, along with consideration concerned to nature of vegetation, density of vegetation, thickness of soil cover, availability of the drainage, etc. Dear friends, in this class we have elaborated about stresses acting on road, both dead and live load, then about the distribution of stresses through different type of pavement and without pavement, then about engineering geological investigations required for identifying new road alignment for construction, then some specific aspects related to hilly road regarding the slope cut, and then the quality of aggregate of material. Thank you very much for your patience.